Hello everyone, welcome to today's video. इस वीडियो में we will talk about how the sums of natural numbers and their powers were actually, found out. So we are going to talk about how 1 plus 2 plus 3 plus all the way up to n is equals to n into n plus 1 upon 2. This is our first relationship, right? And we also know that the relationships like 1 square plus 2 square plus 3 square and all the way up to n square. This is also equal to n into n plus 1 into 2n plus 1 upon 6. But have you ever wondered, like, how do you actually prove the second relationship other than principle of mathematical induction, other than already assuming things? How do you prove it if you were not to prove it using induction? Have you ever wondered? And what about the higher powers of it? So, this is what we are going to discuss. It's a very interesting topic. And with this technique, you should be able to find out anything, any powers on your own. So let's get into it. Obviously, the first sum 1 plus 2 plus 3 all the way up to n, that can be evaluated as follows. You can simply write s equals to 1 plus 2 plus 3 and all the way up to n minus 1 plus n. Correct? You can also write the same s in the reverse order as follows: n plus n minus 1 plus n minus 2 and all the way up to 2 plus 1. Add these both of the equations and you will get s plus s is 2s, and this is simply equals to n plus 1. So if you add n and 1, it gives you n plus 1. If you add n minus 1 and 2, it gives you n plus 1. And similarly, all of these corresponding sums give you n plus 1. How many such terms are there? There are n such terms, right? So therefore, 2s is equals to n times of n plus 1. And this gives you the result that s is equals to n into n plus 1 by 2. Pretty simple, right? And there is a famous story that goes back when Carl Friedrich Gauss actually did this in a class when the teacher jokingly asked, "Can you sum 1 to 100?" And he immediately replied 5050, right? Okay. So, leaving that aside, what about power of 2? So, what about when we have the power as 2? What about k equals to 2? So we are in general interested in the following sum where sk is equals to 1 to the power k plus 2 to the power k plus 3 to the power k and all the way up to n to the power k for n belongs to natural numbers. So we already know that s1 is equals to n into n plus 1 by 2. Now this technique is going to help you to find out any powers as I said. So how do we do that? So we want to find out s2 first. To do that, what we are going to do is as follows. Recall that 1 plus x whole cube is nothing but 1 plus x cube plus 3x square plus 3x. This is pretty much simple from the binomial theorem. So one thing in mind, you must know the binomial theorem. Now, we can simply write this as 1 plus x cube minus x cube is equals to 1 plus 3x plus 3x square, correct? Now, do one thing. You sum all of this from x equals to 1 to n. So basically what happens is this: you sum the left hand side from x equals to 1 to n, where x is a natural number again, and you sum the right hand side in the same manner. So it becomes 1. This becomes x equals to 1 to n 3x, and this becomes x equals to 1 to n 3x square. It's a pretty simple technique, but I'm betting on it that most of the people haven't seen this, so which is why I'm making this video to make sure everyone knows about how these are found. Okay, so first of all, do you realize this is a telescoping series? Because the first sum is nothing. If you write it out this term by term, it simply becomes 2 cube plus all the way up to n plus 1 whole cube, right? And the second x cube term, this simply becomes 1 cube all the way up to n cube. So, and on the right hand side, we already know this is going to be n. We know this is going to be 3s1, isn't it? Because x equals to 1 to nx, it's just s1 because it's the simple 1 plus 2 plus 3 all the way up to n. And this is a required sum s2. Okay, fair enough. Now, in this whole summation, what gets cancelled out from 2 cube to n cube, everything gets cancelled out, and you are left with n plus 1 whole cube minus 1 is equals to n plus 3s1 is nothing but 3 into n plus 1 by 2 plus 3s2. Now, if you were to simply write down the value, you would simply get 3s2 is equals to n plus 1 whole cube minus 1 minus n minus 3n square by 2 minus 3n by 2, right? And therefore, s2 should be equal to n plus 1 whole cube. I'm not going to simplify this, but just so you know that we already know the value minus 1 minus 3n square by 2, and this is minus 5n by 2, and this is all whole divided by 3. And if you simplify this out, you will get the required factorization, which is n into n plus 1 into 2n plus 1 whole divided by 6, right? So this is, now you know that S2 is this. So can you find S3? Yes, of course you can. How? You can simply write 1 plus x whole to the power 4 is equals to 1 plus 4c1x, 4c2x square, 4c3 x cube, and then x to the power 4. In the same manner, simply write down 1 plus x power 4 minus x power 4 is equals to 1 plus 4x plus 6x square plus 4x cube. Sum on both sides, and you would be again left with something like this: n plus 1 whole to the power 4 minus 1 is equal to, this 1 will become an n, this will become 4s1, this will become 6s2, and this is going to be 4s3. You can again find out 4s3 using all the previous values. I hope I made the point clear here of how to find out consecutive powers. All of this is going to be depending on the previous values that you have found, which is why induction works perfectly well here. But this is how those were actually found, because someone actually had to find the values first, right? Induction only works when you have the result in hand. So this video was, I hope it was helpful to understand how recursion is so much important. And if you're preparing for JEE Advanced, JEE Main, ISI CMI, or any other competitive examination like Olympiads or something, you can download the app or go to the website, whose link is in the description. And if you're preparing for JEE Advanced or JEE Mains in particular, you can join the Cheetah batch, which is going on right now. Do not miss, as I take live sessions and you get to interact with me there and solve all your doubts and problems and solve all the problems with other students live in class. So thank you for watching. I'll see you in the next video.